Ever wondered what truly separates a good AI application from a groundbreaking one? Well, it's not just about complex algorithms. It's about thoughtful design. We'll explore how to design AI apps and solutions better, making them more effective, user-friendly, and responsible. To build the future, we must acknowledge the past. The AI we see today is built on the visionary works of pioneers. Foundational concepts established decades ago found the bedrock of modern advancements, illustrating a continuous evolution rather than disconnected breakthrough. Consider Alan Turing, widely acknowledged as the father of theoretical computer science and AI. His work on the universal Turing machine in 1935 and the conceptualization of the Turing test in 1950 were far ahead of its time, laying the groundwork for modern computing and providing a benchmark for evaluating machine intelligence that still spark discussions today. This early theoretical work established the very possibility of intelligent machines. Then there's John McCarthy, who in 1956 coined the term artificial intelligence and created a programming language that became pivotal for early AI development. He essentially established AI as a distinct field of research, giving it an identity and an essential tool for practical experimentation. More recently, Andrew and Richard received the 2024 Turing Award for pioneering work in modern computational reinforcement learning (RL). Their research, often sustained by long-term support like the NSF grant Barto received, laid the conceptual and algorithmic foundation for reinforcement learning. This is critical for many AI breakthroughs we see now, from sophisticated chatbots like ChatGPT, learning through human feedback, in autonomous system. The journey from Turing's abstract idea to the practical application of reinforcement learning in today's AI illustrates a vital feedback. Theory informs practice, and practice challenges often spur new theoretical inquiries. This synergy is key to remember as we design the next. Powerful AI isn't just intelligent, it's empathetic. True innovation in AI begins with deep understanding of users' need, users' pain points, and the context in which they'll use the solution. User-centric AI design isn't about adding AI features for hype. It's about leveraging AI to genuinely reflect users' need and simplify their tasks. Philosophy is embodied in the design thinking process. Empathize, define, ideate, prototype, and test. AI can supercharge this process. In the empathize stage, AI tools can analyze vast data set from social media or customer user insights and hidden needs at scale and speed beyond manual methods. AI processes the data. Human designers are essential for interpreting these insights and forging a genuine empathetic connection. AI amplifies our ability to understand, doesn't replace the human touch. For the define stage, AI's pattern recognition capabilities can aggregate feedback from diverse sources to pinpoint common pain points and quantify experience issues, helping to define problems with greater precision based on data-driven evidence. AI also assists in ideation, rapid prototyping, and analyzing test feedback, making the entire cycle more efficient. AI UX, or user experience. Remember key things. First, consider your user's familiarity with AI and the context of use. Is it for professional task or casual interaction? Second, the complexity of AI algorithm must remain under the hood. Present an intuitive, user-friendly interface. Third, user-centric design is iterative by nature. For AI, this iteration also feeds into AI's own learning capabilities. It learns from user behavior and evolves in a dynamic loop where the user feedback not only refines the design, but also the AI model itself, making the system progressively more aligned with the user need. Data is the lifeblood of any AI system. That's where the data-driven design, or DDD, comes in. DDD means design and development decisions based on empirical evidence from data, not just intuition. In AI, this means data informs everything from feature development to model behavior. Relying solely on gut feelings can lead to ineffective AI, wasted resources, and poor user experiences. The AI systems thrive on both quantitative data, the what, when, how many, and the qualitative data, the why, like user motivation and feelings. While AI models excel at processing numbers, the why behind user behavior, captured through qualitative measure, is often the game changer for creating truly effective and user-centric AI. For instance, metric might show low engagement with an AI feature, but user interview can reveal why, leading to better redesign. The quality of this data is paramount. You've heard garbage in, garbage out. It's especially true for AI. Training data must be representative and high quality. It needs to be diverse and accurately reflect the real-world scenario the AI will encounter. Non-representative data is a primary source of bias and poor performance. For example, an AI model trained only on data from one demographic will likely perform poorly or unfairly for others. When dealing with massive data sets, data sampling techniques like stratified sampling help ensure this diversity and representative fairly. To manage this data flow effectively, we need robust AI data pipelines. These are automated workflows that take data from collection all the way to model deployment and ongoing monitoring. Ensuring data quality isn't a one-time check. It's a continuous responsibility. The dynamic nature of real-world data means that without ongoing monitoring and pipeline adjustments, even a well-built initial model can degrade over time. As AI becomes more powerful, the ethical implications of its design are paramount. Ethical AI focuses on optimizing benefits while minimizing risks like unfairness, lack of privacy violations. Neglecting these can lead to severe consequences, from reputational damage to societal harm. Ethical AI development is not a reactive change, but a proactive, continuous process embedded throughout the lifecycle. A major challenge is AI bias, which refers to systematic error or unfair outcomes and stems from flawed data or algorithmic design. Bias can creep in during data collection if the training data isn't diverse or representative. For example, facial recognition trained mostly on one race will perform poorly on other races. Next one could be data labeling. Human annotator can unintentionally introduce their own biases. And finally, model training, which could have like imbalanced data, or algorithms might inadvertently favor majority. Another common types of bias include selection bias, when the training data doesn't reflect the actual user population. For example, hiring AI trained on past successful candidates who were predominantly male might unfairly disadvantage female applicant if the AI reinforces existing beliefs or trends present in the data, potentially amplifying societal prejudice, can cause confirmation bias. And then finally, stereotyping bias is when the AI reinforces harmful stereotypes, like a language translation tool consistently associating nurse with female pronunciation and doctor with male ones. Biased AI can perpetrate injustices and discrimination. To encounter this and to build trust, we need explainable AI, or XAI. XAI encompasses process and methods that allow human users to understand and trust the results created by machine learning algorithms. It's about opening the black box. Without understanding why AI makes certain decisions, it's incredibly difficult to identify, diagnose, and fix those biases. XAI technique like LIME, which stands for Local Interpretable Model Agnostic Explanation, which explains individual predictions, or Deep Lift, which traces decision in deep learning models, provide concrete ways to understand AI's reasoning. This understanding is vital for debugging, accessing fairness, and building user trust. Investing in XAI isn't just for transparency. It is a fundamental technique required for building fairer systems. Finally, transparency and accountability are users should understand how AI services work, its capability, and its limitation. Accountability involves establishing who is responsible when AI system causes harm, an area with ongoing legislative development. Choosing the right tools is crucial for efficient development, scalability, and maintainability of AI applications. Your tech stack significantly impacts your speed to market and long-term success. For many modern AI applications, a lean Python-centric stack offers rapid development and leverages the extensive Python ecosystem for AI and ML. Streamlit lets you build interactive web apps for your models quickly, often in pure Python, making it great for MVPs and internal tools. FastAPI is perfect for building high-performance backend APIs to serve your AI models. Its asynchronous capabilities are excellent for input-output bound AI tasks, and it offers great speed and automatic documentation. Airflow handles the crucial backend orchestration. Production-grade AI isn't just a model and an interface. It requires robust process for data management and model lifecycle management. Airflow helps author, schedule, and monitor these complex data workflows, ensuring your AI system is fed with fresh data and models are retrained reliably. Together, they create a powerful workflow. Streamlit for user interaction, FastAPI to serve the model logic, and Airflow to manage the data and training pipelines that keep the application intelligent. Designing user experience for AI presents a unique challenge. We need to manage user expectations about what AI can do and cannot, handle probabilistic and sometimes incorrect outputs, and build trust in system whose decision-making system can be opaque. Effective AI UX is about managing this uncertainty and building trust incrementally. Key UX principles for AI include clarity and transparency, making sure that AI's actions are understandable and it clearly communicates its capability and limitations. For example, AI found this based on X, Y, or Z. User control and feedback on how AI empowers its user to correct the errors that it makes, override suggestion and provide feedback. AI should be an aid, not a dictator. Feature like "Do you mean Y" or "Report issue" button are vital. AI behavior should align with user expectation, avoiding surprising changes without consent. Designed for when AI makes mistakes, clearly explain errors and suggest solutions. It should handle errors and it should have minimum cognitive load. Keeping interaction simple, users decipher complex AI output. This leads us to human in the loop or HITL design. HITL is a collaborative approach that integrates human judgment into AI development and operations. Train by labeling training data, evaluating model performance, providing feedback on predictions, and crucially handling edge cases or ambiguous situations where AI has low confidence. These benefits are immense: enhanced accuracy, bias mitigation, increased transparency, and improved user trust. For instance, a content moderation AI might flag content, but a human makes the final call, and this feedback refines the AI. HITL acts as a vital bridge between AI's computational power and the nuanced understanding required for real-world complexity and ethical judgment. Testing AI is more complex than traditional software testing. It involves validating the data, the model's learning process, its prediction, and its performance in dynamic real-world scenarios. Effective AI validation is a tripartite endeavor, focusing on the data fueling the AI model itself, and the ecosystem deploying it. Weakness in any one area can undermine the entire solution, and some of the key best practices include: know what you're testing for accuracy, fairness, robustness, and your KPIs. Just define your objectives clearly. Next, on the quality, the completeness, and the representativeness of your data by detecting biases and data drift, by focusing on a data-centric testing. You could also do model-centric testing, wherein you evaluate the model's architecture and predictive performance using matrices like accuracy, F1 score, perplexity, or FID, or even depending on the model, some other measure. And finally, testing it for ethics, specific tests for fairness and as any potential harmful outputs. AI models aren't static, they exist in dynamic environments. Deploy and forget mentality is particularly dangerous. Continuous evaluation and refinement are super critical for AI. AI models can degrade as real world data patterns. That's why continuous monitoring is super essential. You could also do A/B testing, just comparing different model versions or UI features in a live environment to see which performs better on key metrics like user engagement or accuracy. And this provides empirical evidence for what truly works. And establishing robust feedback loops like thumb up or thumb down rating or error reporting to gather insights on AI performance. This feedback is invaluable for targeted model updates and improving data quality. This feedback loop from production back to refinement is non-negotiable for sustained AI performance. So designing better AI means putting users first, being data-driven yet ethically aware, choosing the right tools, crafting intuitive experiences, and committing to continuous refinement. The future of AI is not just about what we can build, but what we should build. Positive AI outcomes are not guaranteed. They are the result of intentional ethical design and development practices. Let's commit to responsible innovation, creating AI solutions that are not only intelligent but also fair, transparent, and beneficial for all. The AI design journey is one of continuous learning,